Okay, today for Algebra 2, we're doing 4-4. I'm sure you have your notes. They might seem overwhelming since it's like 3 pages stapled together. But we're breaking it into 2 days. It's just all the same topic. So first of all, our objectives are to find the determinants of a 2 by 2 and 3 by 3 matrices. Okay, we're going to do that today. Objective 2, we're going to solve a system of equations using Cramer's rule. We're going to start that today. And objective 3, we're going to say for tomorrow, finding the area of a triangle using a determinant. So some pretty cool uses. But that'll be tomorrow. And we'll work on solving some systems more tomorrow as well. So first of all, with a determinant, we have a 2 by 2 determinant. So I have that 2 by 2 up here, it says, but a determinant. Okay, it's a related real number. It's the difference of the products of the major and the minor diagonals. We've talked about these. We talked about the major diagonal. Okay, the major diagonal is the diagonal from the top left to the bottom right of a square matrix. So if I look at this matrix over here at matrix A, this right here is my major diagonal. It's the top left to the bottom right. Now, the minor diagonal is the opposite. It's from the bottom left to the top right. So if I start here and go this way, that's my minor diagonal. So to find the determinant in that case, okay, I'm going to take, if I look at my major, I'm going to take A times D, which is what this says, right? I have A times D, and I'm going to subtract, okay, my minor determinant, or my minor diagonal. So C times B, and that's what we have here, C times B. And that difference is my determinant, okay? So a couple ways we can denote determinant. You'll notice it says DET here, determinant A, which is a 2 by 2, or it looks like it's inside absolute values. That's also a symbol for the determinant of A, okay, is to have that absolute value. So let's actually try this out. Sorry, I gotta get my board to clear. Doesn't want to clear. There we go. Okay, so in example 1, it says find, okay, and it has kind of these absolute value symbols again. Doesn't really look like the matrix. So we're looking for the determinant. So we take the major, so 3 times 4, okay, is our major. And then we do 2 times 5. That's our minor. So then we have, it's 3. Let me go back and change my colors here so it's less confusing. So because we have 3 times 4 from our major determinant, so I wrote 3 times 4 so you could see it, which is 12. Okay, and then the 2 times 5, so it's minus 2 times 5, which is 10, so minus 10. 12 minus 10 is 2. That's my determinant. Okay, that's it. So let's try the next one together. All right, so we're going to do our diagonal. So we've got 7 times 6. Okay, so this equals, I'm going to go ahead and write 42 here. Okay, 7 times 6 is 42. Let's do our minor diagonal. -1 times 9. So that's -9. So minus -9 equals 42 minus -9. Well, that's the same thing as plus a positive. So 42 plus 9 is 51. And you'll notice I had that right here, so check. We got it right. We just found a determinant of a 2 by 2 square matrix. All right, now it's going to get a little tricky, but just a little. This time it says to find the determinant of a 3 by 3 matrix. Okay, that's a little more complex, but we're going to rewrite the first 2 columns to the right of the matrix. So you'll notice here is my 3 by 3 matrix. Okay, and then so I'm going to take the first 2 columns, these 2 columns right here, and I'm going to rewrite them to the right. So I'm just like repeating the pattern. So we have A, B, C, our matrix, and then A, B repeats. So I just brought those over here. Okay, so far that's the first step. We just rewrite those first two columns. So it's not a square anymore, but we have to, because here's the thing, we're going to use the same diagonal concept. So if I have a diagonal here, I need more than one diagonal. I need it to include all of them. So I had to rewrite them so I could get a second diagonal and a third diagonal for each of those elements, A, B, and C. They each have to have a diagonal. And then the same way for the bottom, we have to have a diagonal for G, for H, and for I. So some of the numbers we're never going to use, but some of them we are. Okay, but we rewrite those first two columns so we can have all the diagonals that we need. Okay, so let's look at this a little bit more. All right, so step one is to rewrite these those two columns to the right. Now, we're going to find the sum of the products of each set of diagonals. So here's the thing. I like to organize my work from the top, like the major diagonals, and then the minor. So we're going to take A times E times I, and we're going to add that to B times F times G, and we add that to C to D times H. Okay, so we're finding the sum of each of those products. And then we do the minor. So we're going to do G times E times C plus H times F times A plus I times D times B. And then the next thing we do is we subtract these, and it's going to be the major minus the minor. Okay, so it would be AEI, or sorry, the quantity AEI plus BFG plus CDH minus the quantity GEC plus HFA plus IDB. So it's always the major, the sum of the major, minus the minor. So the determinant, okay, is the difference, because we're subtracting, of the major and the minor diagonals. Excuse me. Okay, let's try this out. I know, again, I know it can kind of look a little daunting, but we're going one step at a time, and you guys are going to do awesome. Like, you guys have rocked matrices so far. I've been so impressed. So let's check this out. So that 3 by 3 determinant, again, the terminology we can use is DET, so the determinant of A, or it looks like this absolute value with A in it. And so this is just repeating what was on the last page. So this is that last piece. We're going to rewrite it there. So find the determinants. So here's our matrix for the first one. I took these first two columns, I rewrote them to the right. Okay, we see the 2, the 1, the 5, 3, 7, 2. So I rewrote those first. Now, I'm going to do my majors first. 2 times 3 is 6, times 6 is 36. That's where that came from. 1 times 4 is 4. 4 times 7 is 28, so plus 28. 3 times 5 is 15. 15 times 2 is 30, so plus 30. All right, let's go the other way. So 7 times 3 is 21. 21 times 3 is 63. 2 times 4 is 8. 8 times 2 is 16, so I have plus 16. And the last one, 6 times 5 is 30. 30 times 1 is 30. Okay. So far, hopefully it doesn't seem so bad. Sometimes I think it's easier with numbers than it is to like have the letters when we have A times E times I plus. It's like, what? Okay, so now we need to subtract these two. But the deal is this one has to come first. Okay, we subtract them, the major goes first. So I've rewritten it down here. The quantity 36 plus 28 plus 30 minus the quantity from the minor diagonal, 63 plus 16 plus 30. So that equals 94 minus 109. So negative 15 is my determinant. So I should write A, the determinant of A equals negative 15. I probably should have written that out there to get you in the habit of seeing that determinant terminology. Okay, so let's try B together. So it's a 3 by 3. So I'm going to take these two columns and I'm going to write them to the right. So I'm going to write 9, 8, 6, 5, 3, 2. Okay, and then I'm set to get started. So let's do the major diagonals first. 9 times 5 is 45. 45 times 1 is 45. So 45 plus 8 times 4 is 32. And I'm going to grab a calculator to check my work since I'm recording in the dark. I'd hate to make a mistake because I do that when I have the pressure on. So 8 times 4 is 32, times 3 is 96. All right, and the last one. 7 times 6 is 42. 42 times 2 is 84. Okay, now let's go the other way. So 3 times 5 times 7. Sometimes it does get a little hairy to read some of those, especially when I use the colored marker. I usually write lighter when I'm doing them myself. So 3 times 5 is 15. 15 times 7 is 105. Okay, plus. Then I've got 2 times 4 is 8. 8 times 9 is 72. Plus. Then I have 1 times 6 is 6. And 6 times 8 is 48. Okay. So there I've done all my work. Now, if you want to go ahead and sum these, and you can show me some work. So like 45 plus 96 plus 84 here equals, we could say, well, this is 225. If you want to go ahead and do this step here and then subtract, show me your subtraction, I'm okay with that. So for the minor diagonals, the sum of the minor diagonals, 105 plus 72 plus 48. Again, I'm putting in my calculator. Okay, that equals 225. I should have changed my pen color there. Sorry. So we're going to take 225 minus 225. Again, I took this one first. You don't know that, but I'm telling you. Took this one first, subtracted this one, and so that equals 0. So the determinant, we're going to call this of matrix B, equals 0. And hey, here was my answer. And check it out, we got it right. So that is how you find a determinant of a 3 by 3 matrix. Okay, so now we're going to get into solving a system using a matrix, or using determinants, pardon me. But we also need the matrix. Okay, so let's check this out. Solve a system using determinants. Well, first of all, we did this yesterday in class. Okay, so we have to take the system of equations and put it into matrix form. So remember, we have 5 and we make it a negative 3. There's nothing in front of the x, so it's a 1, and this is a positive 4. Then we have our x matrix, so the x and the y, and we have our constant matrix. Remember, we had the a is the coefficient, c is the constant, so our answers, the 9, it equals 9 and equals 11. So we had all that we talked about yesterday. Okay, so we're taking that and putting it into this matrix. So now it says, create matrices A sub x, notice that, A sub x, and A sub y by replacing the coefficients with the constants. Say what? That's pretty awesome. Okay, so we're going to replace these. So I've made them a little bigger. So we've got A sub x, okay, equals. So I'm replacing the coefficients of each variable with the constants. All right, so we replace the first one to get A sub x. We replace that first column with 9 and 11, the constants. We leave the negative 3 and 4 that we had up here. We're going to leave those. So for A sub y, we put the 9 and the 11 in the next column, and we leave the 5 and the 1 in the first column like they were up here. Okay, but we replace the coefficients with the constants. And we put the x in this column, because again, if we would lay your x down, or when we wrote them even, from our equation, the x's were in the first column, the y's were in the second column. Okay, so we created the matrix A sub x and A sub y. Okay, so that was step 1. So then it says the values of x and y, the values, here we go, of x and y can then be found using the determinants. And we have a formula. X is equal to the determinant of A sub x divided by the determinant of A. Well, that means we need to go back and actually find the determinants of these. We did all this work, but it's not going to do us any good if we don't find the determinants. So let's clear this and do some determinant work. Okay, so we're going to go all the way back up here to A and find the determinants of A. So we did the major, 5 times 4, and then minus the minor, 1 times negative 3. That equals, 5 times 4 is 20, 1 times negative 3, so it's minus negative 3, which is the same thing as plus. 20 plus 3 is 23. Again, that's the determinant of A. Let's look at the determinant of A sub x. Okay, we're going to do our major diagonal, 9 times 4, okay, which is 36. And then our minor, 11 times negative 3, okay, so it's minus. So minus 11 times negative 3 is negative 33. This is the same thing as plus. 36 plus 33 is 69. And again, that's our determinant for A sub x. And let's do our determinant for A sub y. Major diagonal, 5 times 11. Okay, I'm going to skip over here. That's 55. The minor, 1 times 9, so that's minus 9. 55 minus 9 is 46. Okay, so we took the system and we put it into matrices, to the matrix form. Okay, then we made a matrix for A sub x and A sub y by plugging in the constants. Then we found the determinants of all three, of A sub x, and A sub y. Now we can use these formulas. So again, x is the determinant of A sub x. Well, A sub x was 69. So that's why we have 69 divided by the determinant of A was up here at 23. 69 divided by 23 is 3. For y, we want the a sub y determinant, which is 46, divided by the determinant of a, which is 23. 46 divided by 23 is 2. So again, we can, like we've been doing throughout the whole year, writing these answers as an ordered pair. X is 3, y is 2. So our solution is 3, comma 2. That's your final solution, your final answer. Okay. There's a lot in this lesson. Like I said, we're not quite done yet. All right, so we're not quite done yet, but we're close. Okay, so what we just did is called Cramer's rule. Okay, so if you go on to your next page, it is, okay, Cramer's rule is a system of equations represented by the matrix equation A times X equals C, and it has the unique solution. Okay, and so we did this. We did X equals the determinant of A sub X divided by the determinant of A. Y equals the determinant of A sub Y divided by the determinant of A. And this is going to continue. If you have a Z, then it's going to be A sub Z, okay, the determinant of A sub Z divided by the determinant of A. Maybe it's going to be A sub K, A sub L. It doesn't matter. It's going to keep going. But the coefficient matrix and so A is the coefficient matrix and the determinant of A cannot equal 0. A sub X, we did. Okay, that's the matrix that's formed by replacing the coefficients of X with the constants. We did that. A sub Y, the matrix formed by replacing the coefficients of Y with constants. We did that, and so on. Now, if the determinant of A equals 0, the system does not have a unique solution. So that's kind of a nice one where you can stop at. It does not have a unique solution. But that is, this Cramer's rule is what I just laid out on the previous one. So we've already done one together. Let's look at one more, and then we'll do one together. Okay, so solve using Cramer's rule. Okay, so that first thing is to put this into a matrix form. So we have 4, 3, and 6, -1. And I didn't even put it in the A times X times C form. I was kind of taking a shortcut because I didn't really need it, I guess. So I cheated and took a shortcut. All right, but I went ahead and found the determinant of A. Right, 4 times -1 is -4. So we have here 6 times 3 is 18, so we have -18. -4 minus 18 is -22 for the determinant of A. A sub X, that's when we take our constants and we put them in that first column because that's where our X's are. So instead of having 4 and 6, we're going to put in 8 and 1. And that's the 8 and 1. Okay, and then we do our major diagonal. 8 times -1 is -8, minus 1 times 3 is 3. -8 minus 3 is -11. Let me go back and do -22 here. All right, then A sub Y. Let's see. I'll try to. Sorry if you hear that scratching of the pen. I try not to get to that. Okay, so now for A sub Y, we're going to take these, the 8 and the 1, the constants, and we're going to put them in the second column because that's where the Y's are. So we have them in that second column. Okay, major diagonal. 4 times 1 is 4. 6 times 8 is 48. So 4 minus 48 equals -44. That's the hard part. Now the easy part comes. So to find x, right, it's the determinant of a sub x, which is negative 11, divided by the determinant of a, which is negative 22, and we get 1/2. Okay, the determinant, or to find y, it's the determinant of a sub y, which is negative 44, divided by the determinant of a, which is negative 22. And so we get 2 for our y value. So we write it as an ordered pair, 1/2, comma, 2. All right, so let's try b together. All right, so we're going to call this b. All right, so b is going to equal, or determinant, pardon me. No, hold on. My pen is not working. There we go. All right, so first of all, b is going to equal 3, negative 8, 7, and positive 4. Okay, so the determinant of b then is going to equal 3 times 4 is 12, minus 7 times negative 8 is negative 56. So that's addition minus a negative is 68. Okay, that's 68. Okay, I was looking at that one. Yeah. Okay, so now let's do b sub x. So we're going to replace this column with the answers, 58 and 22. And we're going to keep the negative 8 and 4. Okay, so the determinant of b sub x equals. I'm going to grab my calculator again because those are some bigger numbers. Okay, 58 times 4 is, that can't be right, I got 0. 232. I was like, what? Let me check that though, because 58 times 4, 232, okay. 22 times negative 8, so this is going to be minus negative 22 times negative 8 is negative 176. All right, so 232 plus 176, because this minus a negative is the same thing as plus a positive, equals 408. And let's do our next one, b sub y. Okay, so I'm going to throw these numbers in here, and we're going to put our solutions in the y column, so 58 and 22, and we're going to put the 3 and the 7 back in the first column. Those are going to stay like we started with. Okay, major diagonals, 3 times 22 is 66, but let me write this here. I don't want to, I was like, there goes my board again. Okay, so we want the determinant of b sub y. Don't want to skip a step. So 3 times 22 is 66 minus 7 times 58. 7 times 58 is 406. Okay, 66 minus 406 is negative 340. All right. So now, for our final stages in this, right, to find x, we're going to do the determinant of b sub x divided by the determinant of b. So b sub x is 408 divided by determinant of b is 68. So let's check that. 408 divided by 68 equals 6. Y is going to be the determinant of b sub y, divided by the determinant of b. Okay, b sub y is negative 340 divided by 68. So let's try that. 340 divided by 68. It's going to be a negative 5. So my ordered pair is 6, negative 5. Okay, and we are done for today. You're probably like, whew, thank goodness. Praise God. That's good. So we had a lot of practice. We did 3 problems that use Cramer's rule, but I wanted to make sure you had lots of practice seeing it, so it's not so intimidating when you start doing it on your own. So if you have questions or concerns, I will be there tomorrow and we will go through them. But I hope this was helpful and you all were able to follow along. Even if you didn't take all the notes, at least you have 2 examples worked out for you to go back and look at when you're doing your homework, okay? So use those, check your answers in the back of the book like always, and I will see you Wednesday.